Okay, picking up where we left off on page 505, we're talking about the parts of a knowledge management system, and particularly this thing called a knowledge repository, which could be something as simple as a 3-ring binder, but the book is going to spend most of its time talking about, you know, the more technological points of view. They talk about software for sharing documents, and they talk about PDF. That's pretty good. You know, you archive information, you make it available. That's kind of cool. But again, most of these are going to be slightly more complex than that. Okay. They talk about a knowledge map. It's basically a directory, because if you know enough to ask the absolute correct answer, question, forgive me. If you know enough to ask the exact question, then probably you're halfway there to solving the problem. If you've ever done tech support, here's how tech support works. My printer don't work. And you go, oh, okay, well, is it plugged in? And you go through all this kind of stuff. And what they really were trying to say is, I printed this document and the margin was off, okay? But they didn't know how to ask the right question. So Knowledge Map is trying to give you like consider a non-technical perspective. It's table of contents, okay? That says, hey, brake press is making a noise, and you go, oh, okay, that kind of stuff. So it's trying to get you in the right spot, because a lot of people can't get there because their preconceived notion of what the problem is actually helping them and not hurting them. Okay, so now we're talking about the technology to make this thing work. So there's a table that talks about, well, first of all, let's talk about how these things are built. An awful lot of the information that goes into this is a result of some data mining. Okay, you remember data mining from whatever chapter that was in. Yeah, chapter 5. Where they go through and they pull out about a lot of information. For example, it talks about patterns in the data and all sorts of interesting things. You can use that to say, well, wait a minute. When the overtime gets to this amount, then somebody's going to use data mining to make that decision. It says, hey, our costs are going to go up unless we add an extra person to the shift. So that's how that information was gathered. Okay, cool. There's a figure here. I don't know. I'm not familiar with that many of these software vendors. I've seen a couple, but I'm not all that familiar. I've heard of these guys. Moxie. Okay, cool. Okay. So yes, there's software out there that can help you, and the idea is that that you put in all this information. And later we're going to talk about these what's called a shell, where you could buy a knowledge management shell, and it's got everything in it, all the facilities for doing the acquisition and the storage and the sharing and the use, all that's all in there. You just have to plug in all the real data. Okay, so let's continue. Now, next thing they talk about is they kind of take a break from knowledge management, and we later in the chapter we actually do get back to it, but hey, now we're talking about artificial intelligence. So, back in the 50s, somebody coined this phrase, and of course it's been around for quite some time. Kind of cool. So, you guys may remember a couple years ago that, the IBM supercomputer called Watson appeared as a player on Jeopardy, and it was a big news thing. And bottom line is, it did pretty good in a game show, being able to answer questions. They got a goofy little video here of this guy trying to do something. So this is like the IBM booth at some trade show where they're showing off doggone close to, having perfect artificial intelligence. Okay. Almost none of them are done, supercomputers are done like that quite now. Now almost everything is done in the cloud. So you have a supercomputer in the cloud, for example, and they talk about this cloud-based Watson is being used by oncologists to fight different types of cancers. And so in the medical field and stock trading, oh yeah, I want artificial intelligence in stock trading. I want to be able to say, if I bought 100,000 shares in this particular industry, how much is the price of the stock going to go up? And so it's going to war game this thing and go, if I bought this many, I bet the stock's going to go up that much. But if I buy this much, its stock's going to go up a whole bunch. So it's going to go through these little war game kind of things and try to help you come up with a decent answer. Okay. the next thing is kind of weird. They talk about the nature of intelligence. This is kind of an interesting topic because they talk about the Turing test. The Turing test was the idea that to find out whether or not you have perfect AI is you set up a test where people or judges, ask questions of the computer and get responses back. And if they can't tell that they're talking to a computer or a human, well, then they've passed the Turing test. Okay, that's kind of the thing it works. Okay, so the idea is no one's quite made it yet. We're getting really, really close. Probably only a few years before we can not be able to tell the difference. There's a bullet list here that talks about the types of problems or types of thinking that you and the computer both do. And some of this may sound perfectly normal, but you can imagine how difficult it might be for a computer to do the exact same thing. So the first one in this bullet list is ripe for test questions, so pay attention. So learn from experience and apply knowledge to acquired through experience. So here's a scenario. Let's say you're the computer and you're trying to do something and you got 5 choices, but you picked choice number 2 and it worked like a champ, and so you don't ever bother to look at any other choices. The only way you learn is when you fail. Like you pick option number 4 and you go, well, that didn't work. Well, let me try number 2, and you go, oh, okay. So you've learned something if you fail. If you don't fail, you practically don't ever learn anything. Okay. So it's easy for humans to pick this up. Humans, small babies at 18 months can do this. Computers, whew, that's a little bit more complicated. Okay. So that's one example of where computers have a tough time doing what we do. Handle complex situations. Okay, computers are pretty good at that. So, maybe this thing is just got too many variables. I mean, I'm trying to predict the weather in Central Texas 7 days out. I need tons of data, and I need all sorts of models. It's very complex. No human is going to sit down and do that by hand. Okay, you have to use the computer to do that. Solving problems when the huge chunks of this stuff ain't there. Okay, that's very good. If all the parts to the puzzle were there, oh, anybody could do this. But it's going to take a computer to be able to say, well, now look, this is huge, important information that just ain't there. And so I'm going to hand this off to the computer to run through some what-if kind of drills. Remember we talked about the different types of decision types where, I don't have all the information. Remember all that? Of course you do. Okay. Determining what is important. Computers have a tough time sometimes figuring out what is trivial and what is not. Like you're trying to solve a problem and this one little thing pops up and it's terribly minor, but the computer comes to a screeching halt and says, oh my God, the sky's going to fall. And you go, no, that's not important. Move on to continue solving the problem. Humans are pretty good at figuring out what's important and what's not. React quickly and correctly to a new situation. Again, humans are kind of have a leg up on computers because computers can do things that it knows about. But when you throw something completely new to it, the computer's going to have to be able to adapt quickly to build a new set of rules that it didn't have before. I mean, we humans do this all the time. You jump in a brand new car you've never been in before and you go, wait, where's the light switch? Dang, is it over here? No. Is it on the stock? Is it on, whatever. We're pretty good at figuring things out when we have a new situation. Computers a little bit more tough. Understanding visual images. Now this used to be the purview of humans. Humans were very good at this. Now computers are fantastic at this. Facial recognition, like the Minority Report kind of a scenario where you're walking down the street, it does a facial recognition and starts showing you advertisements that are targeted to you. Yeah, that's some good stuff. Process and manipulate symbols. Again, humans are very good at symbols, letters, numbers, that kind of stuff. And so, yeah, computers are very good at doing two-dimensional symbol kind of thing. They're just now getting to the point where they can recognize three-dimensional shapes as well as we can. Be creative and imaginative. This is probably the toughest for the computer to do, because this is really the purview of the human. Okay, the human is the one who have scenarios where something weird happens and they say, what the heck, let's try this. This might work, and then they have a fantastic outcome. So being creative and being imaginative is probably the hardest thing to do for a computer. Shall I repeat that maybe? That of all this list, the one that's the hardest for the computer to do is to be creative and imaginative. Now, why on earth do you think that the professor would repeat that? I wonder. Okay, use heuristics. Remember, heuristics is the rule of thumb. Humans do that very well. Computers do it fantastic. Okay, so those are kind of good things to think about, because artificial intelligence is not completely there. Okay. The next thing they're going to talk about is this brain-computer interface. Right now, most of us are using our fingertips to do input and our eyeballs to do output. That didn't actually make any sense, but yes, it does. Okay, we're using our fingertips for keyboards for input, and we're using our displays and eyeballs for output. Now, there are lots of other ways to do that. You could have voice recognition, or you can have sound, all these other kind of things. But most of us are using, touch and vision. But you could bypass all of that and go directly to the brain. Instead of having me type something, or speak something, you could go directly to the brain. There's been a toy out there in the world for quite some time, okay? And it's called MindFlex. It's a game from Mattel. It's dirt cheap. Oh, give me a break. In this game, actually, you put a little headset on and you steer this little ball through this maze using only your head. You just think about it and you go, turn left or speed up, slow down. And as you're thinking, the ball responds to that. Now, this has been out again since 2009 or something. It's not new technology. So this is a trivial example of the brain-computer interface, the BCI. So obviously what they're after is a little bit more. I mean, clearly what they're after is somebody has a disabled limb or missing limb, and you put this little doodad on somewhere, maybe on your shoulder or on your head, and when you think, okay, I want to move my arm, the arm will move. Now, they have those now, but they're very, very slow. Okay, cool. So robotic limbs exist, but, you're not going to be catching a baseball with it. You're not going to be going, got it. It don't move anywhere near fast enough for that. Okay, so we're still working on this brain-machine interface. Cool. All right. The next one talks about the different branches of AI. And so they talk about robotics and vision systems, natural language learning systems, neural networks, and expert systems. We're going to go through each one of those one at a time. So the first one we're going to talk about, I don't know why they're not in order here, but the first one we're going to talk about is expert systems. So expert system is all about trying to take a junior operator and say, with this expert system, you can solve some really cool problems. So you're a brand new brake press operator, and this is the first time, your first day at the job, and some older guy is going to be standing there saying, here's how you do this, okay? And you do this, and you do this, and you do this, and he's going to show you how things work. That's kind of sort of what an expert system is supposed to do. Instead of having an older person to help you out, you actually have an expert system which is composed of many experienced people inputting into the system. Now, these things could be very simple. You're a sewer plant operator and the pH went up. And so you look at the little checkbook and says, pH too high. And the answer is, add this. Okay, that's your expert system. Okay, this is a good place to stop for the 15-minute mark. And we'll finish this up. Well, maybe not finish it up. We'll continue in just a minute.